Let's look at 8.2 example 2. We're going to graph y equals ax squared plus c. Now remember, the a and the c cause our graph to transform compared to the parent function. Let's remember what the a does. If our a is positive, then both of the graphs are going to point up, so no reflection happens. But if the a is negative, then our graph is going to end up pointing down, which means it's a reflection in the x-axis. The a value also changes how the parabola looks. If the a value is bigger than 1, then it's going to be a vertical stretch by a factor of a. If the a value is less than 1, then it's going to be a vertical shrink by a factor of a. The c value, remember, tells us about the vertical translation. If c is positive, it translates up, and if c is negative, it translates down. Let's take a look at example 2 step by step. So in this example, we are going to graph g of x equals 4x squared plus 1, and then we'll compare the graph to the parent function. So again, we're going to start by making a t-table of values, putting 0 in the middle, going down by 1s and up by 1s. We can take these x values and plug them into this equation and find these g of x values or the y values. You could also plug the equation into your calculator into y equals, hit second table, get the numbers from there. If I plug in negative 2 squared is 4, times 4 is 16, plus 1 is 17. Plug in negative 1 squared is 1, times 4 is 4, plus 1 is 5. Plug in 0 squared is 0, times 4 is 0, plus 1 is 1. And then the rest of the table is just symmetric with the beginning. Since this is 17, the last one's 17. Since this one is 5, the second to last is 5. These should always be symmetric. Now we're going to plot the points and draw our smooth curve. Here's the point negative 2, 17, the point negative 1, 5, 0, 1, 1, 5, 2, 17. Connect the points with a smooth curve parabola like this. Let's describe the transformation. We're going to talk about the 4 first, the a value. So since the a is positive, the graph is still pointing up. No reflection happened. And since 4 is bigger than 1, this is a vertical stretch by a factor of 4. And you can see how stretched out this parabola is in comparison to this black parabola, which is the parent function. The c value plus 1 is the translation. The vertex was at 0, 0. Now the vertex is here at 0, 1. So this is a vertical translation of up 1. So both graphs open up. They have the same axis of symmetry. The graph G is narrower, and now the vertex is 0, 1. So the graph of G is a vertical stretch by a factor of 4 and a vertical translation 1 unit up of the graph of F. Let's take a look at another example, and let's let Big Ideas explain it.
Graph g of x equals 2x squared plus 4. Compare the graph to the graph of f of x equals x squared. Begin with the graph of f of x equals x squared. Then make a table of values. Substituting negative 2 for x in the function g gives g of x equals 12. Similarly, when x equals negative 1, g of x equals 6. When x equals 0, g of x equals 4. When x equals 1, g of x equals 6. And when x equals 2, g of x equals 12. Next, plot the ordered pairs negative 2, 12, negative 1, 6, 0, 4, 1, 6, and 2, 12. Then draw a smooth curve through the points. Both graphs open up and have the same axis of symmetry, x equals 0. The graph of G is narrower, and its vertex, 0, 4, is above the vertex of the graph of F, 0, 0. So the graph of G is a vertical stretch by a factor of 2 and a vertical translation 4 units up of the graph of F.